Hey everybody, we're back to math. So I'm going to do two examples of solving with inequalities. And I think we're going to just do two-step equations, okay? So let's just make it up for fun, shall we? How do you do, everybody? My favorite variable, x. And we're going to graph when we're done. Example 1. I don't know. It doesn't really matter, to be honest. So just like before with our relationship, right? This time it's an inequality, but you still can have, calling it a balance line doesn't work for this one. Sorry, Alexa. But it still can have the relationship, and whatever you do on this side, you have to do on this side to keep the relationship true. Okay? So we're going to do this one, which is a little straightforward, and they're going to do one, this little tweak. Okay? And students often get confused by. Okay? So here we go. We have x. So where's our relationship? It's here. Where's our variable? It's here. We have to do inverse operations to solve. We can either divide by 2 or add 6 as our first step, because those are both things linked to the x. Adding the 6 back is usually easier first. So that's what I'm going to do. Add 6 to both sides. Now you'll notice this thing is equal, but this remains the inequality. So 2x is greater than or equal to 2 plus 6 is, survey says, 8. Okay? Multiplied by 2, so we need to divide by 2. And we get x greater than or equal to 4. Okay? We're going to do a number line so we know what we're talking about. Positive side, negative side, right? Easy peasy. It doesn't really matter. You say 4. Then ask yourself, open circle or closed circle? Remember how we talked about? So open circle means do you include it or not? Open circle, closed circle. So do you include it? If it's open, you don't include it. It's your neighbor's fence. If it's closed, it's your fence. So we look to this, or equal to. That then tells us it is our fence. Fill it in. And we want all the numbers greater than. So what's a number greater than 4? 5. 5 goes that way, right? Versus 0 goes that way. So we're going to go fill it in. Big, bold arrow. Done. And done. You guys follow? Like I said, I'm not doing a whole big extra thing with tons of examples on this for now. Boom, ba boom, ba boom, screenshot it, boop, and then graph it. I mean, yeah, because we're getting rid of this now. Get your screenshot. Okay. 2. Example 2. This one's going to take a little more, okay? That's why we had to kind of roll through example 1 quickly. Sorry, I have to do the numbers in my brain real fast. That should do. Okay. Throwing in some negatives. We're going to see what happens. Yeah? So, when there's nothing written here, it's a phantom what? It's a phantom plus sign. Plus means operation is addition. So the inverse of addition is subtraction. So we're going to subtract 8. Oh, I'm sorry, I jumped the gun. Here's our relationship line. There's our variable, right? So we want to get rid of this first. This became the identity. 8 minus 8 is 0. We don't typically write the identity under addition / subtraction. But we have to bring the rest of this down, right? We talked about this in our videos about just solving equations. So we have negative 3x is less than or equal to negative 7 minus 8. Let's number line it, but let's not number line it. We're getting more negative, but we can sum them. 7 and 8 is 15, but it's more negative, so it's negative 15. Okay? Oh, we're getting some glare from my windows. Don't bother me. All right. So this is where students get a little thrown off when it comes to inequalities. So let's go right after this. We're going to have to write this twice. I'll do the other one in green, maybe over here. Let's go right after this as though we were doing this with an equal sign. Okay? So this is being multiplied. So the inverse of multiplication is division. The number we have to divide by is negative 3. Any number over itself is 1, which is the identity under multiplication, so we're left with just x. Negative 15 divided by negative 3, negative over negative is a positive. 15 divided by 3 is 5. Now, I know I jumped through that. We haven't done a lot of videos on signed numbers in multiplication and division, but I'm going to trust you had a decent 5th, 6th grade education on that. Maybe I jumped past. But what happens to our relationship? Okay, now, some of you might remember or may have already seen or might know, you have to, it's not that you have to as in something to memorize. I'm going to show you why what it is. You have to flip the sign. Okay? So it becomes x is greater than or equal to 5. Okay? Now, if you want to number line this bad boy, and you go to 5, right? Well, either way, it's or equal to. Let me see this. So we make our circle. It's our fence, right? Now, the easiest number to check if it works is 0. Okay, and we're going to get to this when we do linear inequalities, I don't know, in a couple weeks maybe. So let's go back into our problem and put 0 in for what? For our variable. And if 0 makes this statement true, then we shade toward the 0, which is true. If 0 makes the statement false, then we go the other way. Okay? So this is how we can check. And then I'm going to show you why with the green marker, remember? So if I put 0 in here, I get 8 minus 3 times 0. Well, what is that? 3 times 0 is 0. 8 minus 0 is 8. Is 8 less than or equal to negative 7? No. That 8 is greater. So this is not our solution. We go this way. Okay? For anyone if that confused you guys, let's say that you thought, again, if you didn't realize you needed to flip the sign, 0 is technically in your solution set, but it doesn't work. So it's got to be this way. If you didn't know that, then don't pick 5, pick 6, right? 6 times 3 is 18. 8 minus 18 is 10, or excuse me, negative 10, and negative 10 is less than negative 7. So we know that's true. All right, I'm going to go the long way around now and show you why that works. About to hit 10 minutes. I'm going to take this and go down here. Okay? My green's really suffering. Negative 3x is less than or equal to negative 15. Okay? Well, this is a negative 3, but it's also, as we did out here, I called this an addition, and it is. And we subtracted it, right? Well, this is a negative 3. That means we could add it. Okay? And now I'm going to get Any number subtracting away itself, you get the identity under addition, which is 0. 0 is less than or equal to, now let's do this in an order we see, 3x minus 15. Now, I put the 3x first because it's what we're used to seeing, okay? You see what I'm saying there? Oy, oy, the glare is bad. I should shut my windows, but then that would be dreary. And I don't need another Manic Monday. You know what I mean? Okay. So now you might say, oh, Becca, you gave us more work to do. Did I? Yeah, I did. But there's a reason this is a shortcut, okay? But you have to know why. It is because of what is actually going on. So now we're going to solve this, which means we would add 15 to both sides, wouldn't we? 0 plus 15 is 15. Is less than or equal to 3x. Divide by 3. Divide by 3. I'm going to have to go way down. 5 is less than or equal to x. But 5 is less than or equal to x is the same as x is greater than or equal to 5. But so you'll know now 5 is the low bound and the rest goes up. You don't switch this on this, you don't switch this here just because it's like something you got to memorize, it's arbitrary. No, nothing is arbitrary in math except for the symbols we use for counting. This is the shortcut of this, right? This was 1, 2, 3 extra steps, and this was just 1. No, this was just 0. So 3 extra steps. But you could do the shortcut, right? But the thing about the shortcut, you have to know you have to switch it. So it's not that it's not that it makes no sense and you have to memorize it. It's that it's a shortcut. The actual way around, the true solution, is via addition. But because you're wanting to switch that around, you have to switch the sign. Because what's essentially happening is your variable is supposed to go to the other side, but it doesn't. So you're just switching everything else. It's like halftime at a soccer game, and I don't know, you're supposed to declare, like, you're supposed to switch sides, and one player refuses to leave their side, so you have to just declare the goals different. Like, it's just, but you have to swap somehow. That's not the best analogy. Anyway, those are 2 examples on solving inequalities. La da la. I hope you're having a great day wherever you are. It was raining, and the sun was out, and the clouds, and now it's sunny again. So we don't know. But it's a fun Monday in the world. So wherever you are, cheers, good luck, happy math. Bye.